Casting, so I'll just fix up the projector in the room as well. And if you can hear me on the Discord, please let me know that you can. Yeah, I didn't actually need to reinstall anything. I just restarted and it worked. So that's usually the right solution. No. All right. Okay. All right, great. So there's a question about, let me, and so I'll answer the questions in a second. It might be that I messed up the typing for problem set 1. So the basic setup for problem set 1 is that you need to trace several function calls. So this is problem set 1. So you have something like this, Q1B, oh yeah, okay, I did mess it up, so this should be C94, 85, 96. So it should be, so really what I meant to say is this, and we'll review vectors in a second as well. So what's the basic idea? So the basic idea, just to repeat what I had done before, so let's have like a really simple function. So I'll name it doublet, and it'll just compute 2 times x for any input x. And let's say that I want to trace, let's say, f of 10. So what does it mean to trace f of 10? Well, it means that step by step, you just compute whatever you can compute. So what does f of 10 mean? Well, f of 10 means this, where x is equal to 10. So that means that the trace would be, what do? You plug 10 into x, and then you plug this, I meant doublet, sorry. Not completely awake today. So you plug 10 for x, and you plug this to x for doublet. So that means that the next thing is going to be 2 times 10, and the next thing is going to be 20, because once you have 2 times 10, all you need to do is just substitute in 20 instead of 2 times 10, and that's the value of doublet 10, because what doublet does is it just doubles whatever the input that you give it, right? So that's a very simple situation. So what I want you to do is to do the 4 tracings of the functions and have ChatGPT check it for you. So I'll just demonstrate the process here. So here is my solution. So I'll go to my friend ChatGPT. There was a question, do I need to use 3.5 or 4? So in my experience, 3.5 just doesn't do a good job. My approach, certainly in the summer, is that I'm not the police. You can do whatever you want. If you don't want to submit it on time, if you submit it kind of next week, Friday, I'm fine with it. It's just kind of in your interest to do the exercises on time, and in your interest to do it in GPT-4, because that just works better. But you do you. I do recommend that you buy GPT-4. I think it's a good investment. So a textbook these days is probably like $150. I don't know how many people buy them. But kind of compared to a textbook, compared to anything, it's really cheap. And kind of as EngSci students, I think you should know what the state of the art in technology is. And for this kind of thing, definitely GPT-4 would be near the state of the art. So anyway, so this is my solution. And in front of that, I'm going to paste the prompt from the assignment. So basically, the entire thing every time is what you give GPT-4. So here, So here I'm basically taking the entire text up to here's another exercise. Please check it by line by line to see if the stepping is correct. And that is when you give your exercise. The reason you're giving this very large prompt is that otherwise GPT-4 would just not do a very good job of checking your work. So basically the way I designed it is I gave a lot of examples of how, in what way it should be picking. In what ways. So I'll paste that. Oops, I did not paste the right thing. So I'll paste the prompt. And now I have the entire prompt and I have the solution at the end. So this is the correct solution. GPT-4 sometimes gives us a different answer every time. So we'll check if it says that it's correct. And as you see, it says the stepping for the code given is indeed correct. Great. So what I can do now is I can get the link for the transcript of this conversation, which anybody can view. So what I'll do is I'll say copy link. And you can do it kind of however you like. You can submit whatever you like, but the way I would prefer it is if you just made a new file, maybe in RStudio, and just said, okay, like this is not Q1, but like Q3, and then say, this is the link. And then for Q1A, you would give another link, and for Q1B, you would give another link, and so on. And I'll just save this file somewhere. So here I'll say save as. So that might look different on different computers. So the simplest thing is to just save whatever you want to do, whatever you want to save, like somewhere. For example, here I'm saving it on my desktop in the folder DS101, but you can save it wherever. And here I'll name it whatever I want. So let's say temp.txt. So now temp.txt is going to exist in this pre-existing folder DS101 on my desktop. You can put it wherever you want. Yes. So now if I go to my desktop, and if I go to my DS101 folder, so here is my temp.txt that has all the information. And now I can go to Gradescope. So this, I think this is actually not the right Gradescope. So what I'll do is I'll open an incognito window to show you what it looks like when you log in from the student side. So just give I have 5 utrono.ca emails, so I can. So this is me as a student. Then I click on the course. So then I'll go to problem set 1, and here you can drag and drop, or I can just open it. So temp.txt, here it's in my recents. You won't necessarily have a recent thing, but you can always go to DS101 on your desktop, submit temp.txt. So it uploads, and here you can see that this is your submission. So on my side, I'll see submissions for everyone, and then I can grade them. So that's the idea. All right. So that's that. I'll switch to Discord to see if there's any questions or anything. There might be broke. Okay, if $20 makes you broke, I have bad news about how much tuition is. Would GPT-3 gives you the wrong answer? So in my experience, sometimes GPT-3 does give the wrong answers. Of course, you get different answers every time anyway. If there are typos, which there very well might be, I'll look right after the lecture and I'll try to fix all of them. Okay. So, all right. So I want to review a little bit of vectors today. And then I want to do kind of operating on data stored in vectors. and then I want to do tables, so which are also known as data frames and tables and so on. So there is like there's like subtle differences which we're not going to get into now. So I'll just do an example. So the way you do a vector is like this. So I grabbed this example. Actually, I was teaching a course in medical school a couple of years ago here at UofT, and I thought what would be a good example for a data set, and I thought, oh, it's like starting salaries for physicians. So this is starting salaries for physicians actually in the US. In Canada it's not nearly as much, in thousands of US dollars, and actually this is from a couple years ago, so it's more now, and this is for different specialties. So this one I know is family medicine because they get the least, and then this is probably neurosurgery or something like that. I don't remember the exact things. I would not worry about it. Most of you are not getting it anyway. So this is what it looks like. So this is just a collection of numbers, right? And like we saw last time, so you can see what the offer vector is in general, and you can access individual elements. So for example, offer at 1 would be 241, and offer at 3 would be the 533 because that's the third element. Okay, so individual entries in the vector are usually referred to as elements. So like we saw last time around, you can apply the same operation to every element of the vector. So you can, for example, say offer is greater than 400, and what you get is 241 greater than 400, so that's the false, and you get 590 is greater than 400, and that's the true, and so on. Are you with me so far? So questions in the room or in Discord? Okay, there's the purple devil face. Okay. Wait. No, it's not devil. What is it? Okay, you got the octopus. Okay. All right. So this is like that. So then we can say, okay, want to get the elements that are greater than 400, and you can do it. So you can say offer is greater than 400, and that would give you the elements that are greater than 400. How does it work? Well, we can trace it. Right, so the way you would trace it is what's offer at 400. Well, offer is this thing, so we can substitute that in. And then in the square brackets, we substitute that in and say greater than 400. So if you're typing this is a really good time to start practicing your copy pasting with arrows, because otherwise it's extremely annoying, right? So again, and I genuinely think that kind of practicing that a little bit can be just useful. So what I did again is I used the arrows to get the cursor here. Then it's on Windows, it's Shift End. On Mac, I hope someone looked up what it is to select the entire thing. Yeah, so Command Shift arrow key, so either right if you're on the left or left if you're on the right. And that selects the entire thing. Then you can do Control C or Command C on a Mac, and then you can do Command V or Control V as much as you can, as much as you want. Right, so this is Command Shift so on PC, this is Shift End or Shift Home going to the left. And then on Mac, it's Command Shift Right or left. Okay. So, all right. So we were here, so we were tracing this, and I just substituted the actual value of offer for offer. And now the next time, what can we do? Well, we can actually evaluate this, right? So what does it mean to evaluate this? It means we're applying the same thing to every element. So that would be greater than 400. I'm again copy and pasting, so that I'm pasting here, pasting here, pasting here, pasting here, and removing the greater than 400. So the next time I got to actually evaluate this and this and this and this and this. So that would be false, and this would be true, and this would be true, and this would be true, and this would be false, because 261 is not greater than 400. And now it's just that when you are, this is called indexing with a Boolean vector. So when you're giving trues and falses in here and you have a vector in here, what this does is just selects the elements that correspond to true and discards the ones that correspond to false. So this would be just the final value, which is 590, 533, 425. So usually you would not trace it like that. The reason I trace, especially in the beginning of the class, is kind of because like you kind of need to learn to read before you learn to write. And I think the analogy here is kind of tracing is kind of equivalent to when you're just learning to read kind of in school before you learn to write. This is kind of like, okay, how do you read eventually? Well, you kind of look at the page and the words kind of pop into your mind, right? You don't explicitly say, oh, like this is the letter X and that sounds like this, and this is the letter Y and that sounds like this, right? But in the beginning, or at least kind of according to some people, there is some controversy about it, but some people very strongly believe that like you really need to learn to sound out the letters one by one so that you know how to make up words out of letters. So not everyone agrees, but this is kind of what we're going for here, is learning to read before you learn to write code. And learning to read sometimes involves just kind of going down to the very, very simple rules about how things work, and then just applying the rules one by one. That's the idea, at least. So, okay. So that's like that. So we saw last time that you can combine things like this. So you can say offer is greater than 400, and this would be falses and trues. And you can also say offer is smaller than 550, and that would be different trues and falses. And you can say, okay, I want it to be true if it's between 400 and 550. So that means it's both greater than 400 and smaller than 550. So we can just write it like that. So I could say and like this. And this would be trues where the element is both larger than 400 and smaller than 550, and false elsewhere. And that's the same as saying true if and only if the element is between 400 and 550. Right? So if we can have that, then we can also say, get me the offers that are between 400 and 550, non-inclusive. How would you do it? You would say offer at, and then you give this vector of trues and falses. And that lets you select the numbers that are between 400 and 550. Fascinating. Okay. So, okay, all right. So that's like that. So you can also do it the other way. So get the elements that are outside of 400 to 550. And two ways you could go about it, right? So you can say, I want this. So this is a bunch of trues and falses. And then I'll just say not that. So not, the exclamation point, inverts true into false and false into true. So this would be, again, a bunch of trues and falses, except the trues correspond to, it's not the case that it's between 400 and 450. Okay? So that would be like that. So another way you could do it is you could say, actually, anyone here or in Discord have a suggestion? And like, if you have programming experience, please like don't suggest things. I want people to think. I guess like it's unclear kind of what the threshold should be in terms of the experience, but like if you feel like kind of you didn't know it before, but now you know, then feel free to speak up. So I want the same thing, but written in a different way. Yes, so there's a suggestion, use or. That's a good idea. So basically, what does it mean to be outside of 400 to 550? Well, one way to think about it is either it's smaller than 400 or it's greater than 550. That's the way it wouldn't be between 400 and 550. So we can write it like that, right? So we can say offer is smaller or equal than 400, or offer is larger or equal than 550. Right? So this, again, a bunch of trues and falses. And it's true when it's more or equal than 400, and it's false otherwise. And this is also a bunch of trues and falses. And then or says if one of those is true, so if it's either smaller or equal than 400, or it's greater or equal than 550, then make it true. So select that element. If it's smaller or equal than 400, or if it's larger or equal than 550. So that would get us exactly the opposite of what we had before. Right? So this is kind of an advanced thing, but if that's the kind of thing you're interested in, that's like an extremely fancy name for it, but this is kind of an application of De Morgan's law, which states that, well, one version of it, that not A and B is the same as not A or not B. Right? So that's a general thing. Like if you think about it logically, that's how it works out to be. Right? So this is not a programming thing, this is just how math works. So like if you're saying it's not the case that both A and B are true, that's the same as saying, well, either A is false or B is false. This is the only way that it's not going to be the case that both of them are true. And vice versa. So I'm not really doing it in this class or really in ESC 180, but if you like to know the names of things, this is the name of this thing. So okay. In general, kind of when you're solving the problem, I wouldn't suggest thinking about it in terms of this kind of algebra, right? I would suggest just saying, okay, like what makes sense? Like I want the offer to be outside the range of 400 by 50. How do I write that? And I think kind of both of those you could come up with, right? So you could say, well, like if it's not between 400 and 550, I'll just write it like that, like not greater than 400 and smaller than 550. Or you might say just, well, if it's outside the range of 400 and 550, how could it be outside of that range? Well, either it's smaller than 400 or it's greater than 550, and that gets you to this. Okay, there is stuff in Discord. Did I write 500? No, look, I didn't write 500 anywhere. So okay. Yeah. So there was so there was a question which I think it makes sense to address. So how do we trace a nested function when multiple functions are connected by logical operators? And the answer is the same way you would trace an arithmetic expression, right? So how would you trace something like 1 plus 2? Well, let me make it like 1 plus 8, square root of that, times 5 plus 2. Well, just step by step, evaluate whatever you can, right? So, and here, well, technically this is just one function, but you could imagine that there is like a function. It's a silly function to write, but you could write it. So you could say, I have a function that just multiplies x by 5. So here I say like times 5, this, comma 5, like so, right? So that's a valid expression. It's the same as before. It's just that I made the function whose job it is to just multiply the parameter by 5, the argument by 5, right? So so this is terminology that you don't really need right now, but here the 9 is called an argument, the x is called a parameter. A lot of the time you would just hear it as parameter always, like the thing that you pass to a function will just say parameter. Technically, like the thing that you pass to the function is an argument, the thing that the function takes is a parameter, but not really important. Okay, so how would you trace it? Well, evaluate one thing at a time, right? So we have times 5 square root 1 plus 8, so the only thing we right now can evaluate is 1 plus 8. So this is 9. So now square root, we can actually write the function square root if you like after the break. Although maybe tomorrow. But for now, we just treat it as like a built-in thing that we can't really trace. We can just say, well, square root of 9, that's going to be 3. So that would be 3. And then actually had times 5, I meant it like this. So now that's going to be like this. And now times 5 and 3, we substitute in. So this would be 5 times 3 plus 2, right? Because we substitute this in and we substitute 3 for x. And now that's going to be 15 plus 2. And that's going to be 17, and we're done. Right. So if those were, if this were something like an or instead of a plus, it works exactly the same way. How do you trace it? Well, evaluate what you can, and then keep evaluating until you get the kind of simplest possible answer. So maybe what the person who was asking was so maybe what the person was asking is what's called short circuiting. So I'm not going to be concerned with that at this point. If you know about short circuiting, the answer is well, you can just skip the assignment. You probably don't really need it. If you don't know about short circuiting, you don't need it right now. Okay, all right, so that's like this. So now let's go back to our vectors. So this is the vector that I have, and let's say that I want to do something like a table, but just with the tools that I have right now. So what I'll do is I have my annual salaries in thousands of US dollars, and now I'll also specify the specialties. So the 241 is actually, like I said, family doc, and this I thought it was neurologist, but actually it's cardiologist. This is out of date anyways, so orthopedic, dermatologist, and this is psychiatrist. Okay. So the concept here is we have two vectors, and we know that offer 1 corresponds to spec 1, and offer 2 corresponds to spec 2, right? So 53 is the salary for ortho. Okay? And this, I see in my notes, this is for 2018. So add, I don't know what inflation was, 20%? I don't know. So yeah, they're doing well. So okay, so let's say that I want to know the specialty that earns the most, right? So it's easy to find out what is the largest salary, right? So you can just do max offer, and that gives you the maximum salary, but that's not what I want to do. I want to find the specialty that corresponds to 590, right? So here it's a small, it's just 5 numbers, so you can just do it by eye. The idea, of course, the whole point of doing data science is to process numbers when you can't really do it by eye because there is too much data, right? So how do we get that? Well, so here's one thing you could do. You could say offer is equal to max offer. What is that going to be? Well, it's going to be false for the locations where the offer is not equal to max offer, and true for locations where it is, right? So that's why we have false, true, false, 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 because only one of those entries is equal to 590. So now that we have this vector of trues and falses, we can say, okay, I'll just pick out the entry that corresponds to true. So I'll say spec at offer is equal to max offer. And I get cardiologist. Why? Well, because offer equals max offer was false, true, false, false, false. And then I said pick out the entry that corresponds to the true. That would be the entry for cardiologist. Okay. So you might like to know what is the location in the vector of the largest offer, right? So the answer is 2. So how do you get the 2? Here's one way. I can say I have my vector of locations, so this would be 1, 2, 3, 4, 5, right? Because location 1 is 1, location 2 is 2, location 3 is 3, and so on. And now out of those locations, I want to pick out the location that corresponds to the max offer. So it's the same thing, except instead of looking in the specialties vector, I'll look in the vector of 1, 2, 3, 4, 5. And it'll pick out the 2. Does that make sense? Questions? So, all right. So there is a bit of a problem here, which is that this assumes that I know that the size of offer is 5, right? So it wouldn't work if the size of offer had been, 12, if I had 12 specialties. So there is a way to do it. So you can create a vector like so. So if n is equal to, for example, 12, if I say 1 to 12, I'll get the vector 1, 2, 3, 4, 5 up to 12. So in my case, what I want is a vector from 1 and up to the last possible location in the vector. How do I do that? Well, I'll say 1 through length of spec. So length of spec is the number of entries in spec, right? So that would be this, which is the same as before. And now I'll pick out the entries that correspond to the maximum, like this. So in this case, there was just one entry like that, namely 2. So it picked out 2, which again, what we're looking for is the location of the maximum in this vector. Right? So the maximum is 590. The location of the maximum is 2. All right. So in principle, so this is kind of not the most elegant thing you could do, but just for the sake of the example, I can take this and I can say, go to spec and look at the location of the specialty that earns the most, which is 2. So that will, again, give us the specialty that earns the most. This is not the easiest way to write it, but you can write it like that. Right? So let's maybe trace it, because I feel like some people might be confused a little bit. So let's say that I want to trace this. So how do I do this? Well, again, I substitute as much as I can as soon as I can. So here, what can I substitute? Well, length of spec, I know, that is 5. Max of offer, I know, that is 590. So next step, again, substitute as much as I can. So offer equals 590 would be false and then true and then 3 falses. Just because, well, actually I should have substituted offer here as well. So the offer here would be this. And then, so let's really do it step by step. So I'm missing one step here. Hopefully ChatGPT would know. So the step I'm missing is, now it's a vector where I'm saying 241 is equal to 590, and 590 is equal to 590, and 533 is equal to 590, and 425 is equal to 590, and 261 is equal to 590. And then here, this is 1 to 5, so this I also get to compute now. So this is just C 1, 2, 3, 4, 5. So the next step, here I'm done, but here I can convert this to false, and this to true, and this to false, and so on. So this would be like this. And I'll copy the false. And so another trick, so I select, and then once it's selected, I just press Control V or Command V, and it gets substituted with a false. So that's faster this way. And now we just know that if you have a vector and you're indexing it using the square bracket with falses and trues, you pick out the ones that are true. So that means that here you're left with just 2. And this means that you're picking, so spec actually the whole time should have been substituted. This is going to look ugly. But the first time we wrote spec, and here we need to substitute it like this. So it's annoying, but it has the advantage of being consistent and correct. So that's how it's going to go. And now here we're saying pick out element number 2 from the vector on the left. So this would pick out cardiologist. Make sense? All right. Okay. So let's take maybe like a 5-minute break. I'll try to answer whatever is on Discord, and you can have candy if you're in the room. If you're not in the room, you can go and get candy in your cupboard or something. Can you use Bing instead of GPT-4? Well, so Bing, I'm not actually sure that Bing is using GPT-4 necessarily. It's some kind of version of GPT-4. You can try it and see if it works. I have not tried it. Like for this, I've tried Bing in general. It seems like Bing seems like kind of like a drunk ChatGPT. So, yeah, if you press source here, that runs the entire thing.
Okay, sure thing.
Yeah. Yeah, so I think part of it is ChatGPT is not exactly GPT-4. It's like GPT-4 plus whatever reinforcement learning they did. And that might influence kind of the drunkenness levels. No, they didn't retrain the model. However, the RLHF is quite different, I believe, on Bing and GPT-4. Actually, retraining, one run of GPT-4 is actually, so if you didn't receive an invite, send me email. No, it's not, because it's a different country. So if you didn't receive the invite for Grayscope, just send me email. I'll set you up. So I was saying before, actually retraining GPT-4 is completely affordable for Microsoft. So the estimates that I've heard are like between $1 and $10 million. So like I don't have that money, but Microsoft definitely does. Yeah.
Is there a water fountain in this building?
Yes. You'll have to wander around and look for it though.
Yeah. In the basement.
Yeah.
You gotta go straight, go to the park, usually just go all the way to the front and then turn left, and you go downstairs so you can find the water.
Yeah, so ChatGPT, yeah, so GPT-4 just predicts the next token. ChatGPT, kind of part of the reason it's so engaging and works well is that there is a reinforcement learning algorithm that runs that kind of makes it interact with people better. So they paid people to kind of write Python and then rate responses by ChatGPT that are Python related. But also in general, they have kind of and actually kind of, you're doing it for free as well, right? So like every time you get a response, you can say if the response was good or not. So there's like a little upvote, downvote button, and OpenAI uses that in order to train the model to give better responses. And this is not retraining GPT-4. This is more like making the thing that's on top of GPT-4 answer in such a way that would get more upvotes. Microsoft has not bought OpenAI exactly, but they did give them a bunch of money in exchange for some control, but not like majority control, I believe. GitHub, yes. Yeah, so OpenAI, I think, so it's not quite open anymore in the sense that they don't really release a lot of their models or a lot of their research. However, it's still a nonprofit. So it's not actually like a subsidiary of Microsoft. Sometimes RStudio doesn't let me test multiple functions on the same sheet. I assume doesn't let you run test. You mean when you run them, you get some kind of error, and that's probably just because like you miss. So it would say what the error is, and it would say what line, and you just need to fix that line. Do you need to specify C1 to 5? No. Did I? No, I just said 1 to 5 without C.
Oh.
So the answer is no. So in this step, is C2 a vector with one value, or is it just the numeric value 2? Those are the same things. So in R, you don't have numeric values of 2, you just have vectors of size 1 whose first value is 2. Yeah. So like there's no such thing as numeric 2. Like if it's a variable, it's a vector of size 1. So okay, all right. So I want to do some exercises now, and I'll let you work on them for a little bit. So I want to write a function with the signature lambs below. I guess I'm doing it with underscores now. And the function takes in a vector of numerics. So this just means a vector of numbers. Vec, and returns a vector that contains the elements of vec that are smaller or equal to upper bound. So for example, lambs below, see like 5, 1, 2, 3, and upper bound 2. And that should give me just the ones that are equal or smaller than 2. So this would be 1, 3. So that should compute 1, 2, and that should compute 1, 2. So let me give you a minute to try, and I'll walk around if people are struggling, but I'll just give you a minute to get started. And you can discuss on Discord, but I guess don't look if you want to try to do it yourself, which is a good idea. Yeah, sorry. Okay, so if you're stuck, here's how I kind of suggest approaching that kind of question, and I think basically any kind of question, really, and not just in ESC 180. So we know that it looks like this, right? So that's just in the question. And then what I'm asking you to do. Well, I gave you an example, right? So this should be 1, 2, right? That's what the question says, is fill this in somehow so that this is 1, 2. Yeah.
Does it has to be in order, numeric order?
I mean, kind of not specified, and the rule is usually kind of if it's not specified, you can do what you want, but as it happens here, kind of the simplest thing is will lead you to 1, 2, right? So you can send the code in chat. I'm also going to write it in a second as well. You don't have to send, I don't want 50 solutions. I know the solution. So what do we write in there? Well, it's the same as I'm asking you to come up with a math function that works so that, for example, this is 1, 2, right? So here, I think kind of coming up with this is not necessarily that easy if you haven't seen the trick that we just discussed before the break, right? But with the trick that we discussed before the break, it's pretty easy, right? So all you need to say is, okay, so the general formula is to say, get me the elements of vec that correspond to locations where the element is smaller than the upper bound, right? So this would be vec smaller than upper bound. So this is the kind of thing where I would say from first principles, it's not necessarily that easy to figure out. So smaller equal, I believe I said, right? So not necessarily that easy to come up with from scratch, just kind of composing things. So here is where kind of experience does play a role, right? So if you just saw the example where we did exactly the same thing, you would kind of hopefully remember that it's a little bit like that. And then when you are writing down the solution, well, maybe you write something like this or something that's a little bit wrong, and then you would just try and refine the solution until it works. So let's say that initially I messed up the way I had messed up, and I write vec smaller than the upper bound rather than smaller equal, right? So that's not right because the question said smaller equal, and in the example here I had the 2 and that was supposed to be included, right? But let's say I forgot. So what I would do is, okay, I wrote the function, so in order to be able to try it, I need to run it the once, so R knows about it. So I press Control Enter here. You could also just press source. And now you can say LMs below, and it says, oh, the answer is 1. So at this point, what I would do is I would kind of trace the function, but with R's help, right? So it'd say, okay, it was supposed to be 1, 2, and it's just 1. What do I do? Right? I'd say, okay, well, here it's very simple, so maybe you'll just eyeball it and be able to figure it out. But I'll just kind of model the process here. So I'll say, okay, I'll plug this in. So if I trace it, it's going to be, this is vec, and then this is going to be this, and then I'll plug this instead of the upper bound. And now I can just, so it would be annoying to do manually. I can just ask R, what is this? And R is going to say 1, which I already knew because we already knew that the answer is 1 according to R. So now I can say, hey, like, what's up with that? Can I just see what the values here are? So what I'm doing here is I'm highlighting. So in order to select, I press down Shift, and then I just use the arrows in order to select. So that's how you do it fast. Don't try to do it with a mouse unless you have an external mouse, which I actually recommend for programming as well. And here I see, oh, it's false, true, false, false. So at that point, hopefully I can say, okay, I wanted 2 elements and I wanted 1 and 2. So I wanted this is true and that's good, but I also wanted this to be true, but this is false. And at that point, I would hopefully say, oh, that was supposed to be smaller equal, not smaller, that's why. Or maybe I don't. So maybe I go to the next step. Like that seems unlikely, but in more complex situations, maybe I would. And I would say, okay, so what is this? Again, substitute. So this would be 5 smaller than 2, and 1 smaller than 2, and 2 smaller than 2, and 3 smaller than 2. So this, I can check again that this is 1. Of course, I didn't change anything. It was supposed to be 1. And at this point, I can again say, okay, like this is supposed to be true, and this is true. But this is also supposed to be true, but this is false. And maybe now I'll say, oh, why is it false when it should have been true? Well, it's because it's smaller and not smaller than equal. So at some point, you have to get this insight of where to fix it. But if you're confused, don't know where to proceed, what I would suggest is kind of trace it until it's so simple that you can't go wrong. And a lot of the time, especially in the beginning, people are just kind of staring at the page or at the screen and they don't know what to do. And that's normal, but the answer is not to stare more. That usually doesn't work. The answer is, although I will say that I think one of the skills that you learn in kind of first semester, first year is actually kind of perseverance, in the sense that like in high school, many people, especially the good students, never had a situation where they had to think more than 5 minutes about the problem. So people sometimes just kind of like, they think for 5 minutes, they don't get the solution, and then they're like, what am I going to do? And the answer, yes, like sometimes, although not with programming, but the answer is sometimes, well, like maybe 5 minutes is not enough and you got to give it like another 10. And kind of, I think this skill of actually kind of persevering and saying, okay, like, let me just brainstorm for a little bit more is actually something that's extremely useful in EngSci. Giving up after 20 minutes is also a useful skill, because sometimes people have the opposite problem of just kind of getting stuck forever, and sometimes you got to move on. But also kind of separately from that, if you can, it's much better to do something constructive than to just sit around and hope that the right idea will pop into your head. That sometimes does work, to be honest, but not always. And if you can just say, okay, like what's the next small step that they can do so that they can advance a little bit in terms of progressing on solving the problem, that's usually better. And in programming, the answer is usually, okay, like it doesn't work, I don't know why, I don't really have a clear, like I wasn't expecting it to work because I didn't have a clear idea what I was doing anyway, and that happens to everyone. And the way to get out of this is to say, okay, like let me trace it step by step, let me really break it down into like the very small steps where I just know the rules and I know how to progress. And like honestly, it does help. It's hard to model it because if it's a really simple problem, then like people would say, well, like why are you wasting our time? If it's a very complicated problem, people don't know where we're going, so they also don't see kind of the demonstration of the method. So I think to some extent it's something that you need to try yourself when you encounter a problem that's difficult. Some of it I try to do by like forcing you to trace through code, even though maybe you kind of know the answer for the exercises. So, okay. So I want to do another problem. So a median, I think most people know, but the median of a collection of numbers is the number that's at the middle of the collection. So in other words, a number such that n over 2 elements are small equal than the number, and the other n over 2 are larger equal. So here we're not really worried about even numbers, we don't really care, but let's say that you have something like this. So what's the median? Well, the way to get the median is to first get, so one way to get the median is to first sort. So the sorted version is going to be 1, 1, 2, 2, 5, 10. And then just see, it is an even, yeah, so put in a 7 as well. So what's the number in the middle here? Well, it's the 2. Right? So the median, like if you're thinking about the median mark in a class, it would be the mark that the person who's in the middle of the class got, right? So like half the students got less and half the students got more. So you want to write the function my median, which takes in a vector of an odd length and computes the median of the vector. So for example, my median of this is, like we said, 2, because 2 is in the middle. So I'll start writing this. And again, we know that this is supposed to be 2. And I kind of gave you a recipe for the example here, right? So the recipe is, once you got it sorted, you can just take the middle element. So here, what do we need to do? Well, there's like really several things, right? So, and this is called an algorithm. So an algorithm is just kind of a recipe for getting the answer, at least like for our purposes. So sort the input. Figure out the index mid, the location of the median, the sorted vector. And compute the element in sorted vec at location mid. Yeah.
Professor, does the length thing, when we divide the number by 2, does the Java runs up or runs down?
It does neither. So it actually gives you the exact answer, which is, for example, 2.5. Now, of course, if you want the 2, you can always do 5 minus 1 over 2, and you'll get the 2. So you probably want the 3, so that would be 5 plus 1.
All right, thank you.
Yeah. All right, so I'll do the long version. So I can say the sorted version is sort of vec, right? So if you remember, to sort the thing, you would say sort of vec. And then we'll say the middle is, like we discussed, it's length of vec plus 1 over 2. So this is the kind of thing where you just need to plug in examples and see what works, right? So basically what we're saying is if the length is 5, then the middle element is 3, right? Because the middle of 1, 2, 3, 4, 5 is 3. And 3 is 5 plus 1 over 2. So how do you figure out that it's plus 1? Well, you can, of course, logic it out, or you could just, try different things. It's got to be something like length over 2, but length over 2, if it's an odd length, is a fraction. So you might say, well, like maybe I do a +1, -1, whatever, and you'll get there. And of course, kind of, you don't just plug in the one example. So if I figured it out for 5, so for 5, I know that the answer should be 3. So maybe I figure out the formula, so I'll check then if it also works for like 3 and 7 and stuff like that. In this case, it's pretty straightforward. So it's just like that. And then the answer is sorted vec at mid. So here I kind of followed the recipe here where first said, okay, like we'll call sort of vec sorted vec, and we'll call mid something, and then we'll say sorted vec at mid. Of course, you could also write it all as a one-liner, because like here, basically, at least the way we're thinking about it, is those are just kind of, this is like scratch space where we just say, instead of saying length of vec plus 1/2, we'll just say mid. But we don't have to. We could just directly say sort of vec at length of vec plus 1. Oops. Over 2. And that's all we need. Does this make sense? So, all right. So this is going to be like the hash nerd thing. But yeah, like there was a question of, can you check with ChatGPT whether your code is correct? And the answer is you can try. But ChatGPT is not able to run code, and it's not smart enough to be able to trace through code either. So this is kind of like one of the things. Also, I haven't actually checked for a long time, but so tasks that ChatGPT is not good at include like basically anything where you need multiple steps, right? So, for example, if I ask like something like this, we'll see, like it might have gotten smarter. Okay. Usually this is just made up. We'll try and see. Oh. Well, the first digit is 2, and here it got it right actually. 2008 yeah, so the first 4 digits actually seem correct. Can't do that. So I'll get like the whatever 10th digit or something. So to get the 10th digit, I'll just divide by, well, I'll divide by like 1, 10, 10, and that's this, and I'll subtract that. Not the best way to do it. Okay, so here, so the claim would be that the 10th digit is 3, and this is, yeah, the 10th digit got wrong. So here, like, of course, kind of like anyone who passed whatever, like grade 5 knows how to do it with long multiplication. ChatGPT, however, tries to just treat it as like, what's the next digit, what's the next digit, what's the next digit, and that doesn't work. You have to actually like compute it with, for example, long multiplication, so that's why it messes up. So similarly, if you give it code, it'll try to just kind of say like, what's the vibes here, like, you know, does it look correct? But it's not actually gonna go line by line and check, which is what you need in order to check whether the code actually runs. So those kinds of things you'll see that ChatGPT messes up. Also, you'll see like if you ask it to make like an argument that like write an essay, of course it'll write an essay like better than most people. But if the essay again requires kind of close thinking, where you say, well, like this, so then that it follows that this, so then it follows that this, so then it follows that this. It again requires this kind of step-by-step thinking, which ChatGPT is not very good at. Now, one trick is the let's think step-by-step trick that people discovered with those models, where if you tell it